Hi everyone, welcome to GoClasses. Let's solve this question. Find a recurrence relation for the number of bit strings of length n that contain a pair of consecutive zeros. Okay, so what we want the number of bit strings. How many bit strings of length n have consecutive pair of have a pair of consecutive zeros. Okay, so those bit strings of length n which have consecutive zeros. Okay, so this is the question. So we want to find the recurrence relation. So let's call it Tn. What is Tn? This is Tn. What is this? This is basically the number. This is the number of bit strings. What is Tn? This is number of bit strings of length n that contain a pair of consecutive zeros. A pair of consecutive zeros. So this is your Tn. Okay, Tn. It means this is the number of bit strings of length n that contain a pair of consecutive zeros. So what will be T1? T1 will be 0 because you can notice what is Tn. This is number of bit strings of length n that must contain a pair of consecutive zeros. So length 1, if you see the length 1 strings, these are the length 1 strings. If you see, they do not have consecutive zeros. They do not have a pair of consecutive zeros. So the number of one length strings, T1 means the number of bit strings of length 1. The number of bit strings of length 1. Okay, because T1 means the number of bit strings of length 1 that contain a pair of consecutive zeros, that will be 0. What will be T2? T2 means T2. What is that? That means the number of bit strings of length 2 that have consecutive zeros. So that will be 1, because how many bit strings of length 2 we have? These are the bit strings of length 2, but only this bit string has consecutive zeros. So T1 is 0, T2 is 1. So this is what we want to count. We want to count on the number of bit strings of length n that contain a pair of consecutive zeros. Now this is very simple to count. Now you can notice. So this is what we want. We want Tn. Okay, the number of n length bit strings. This is n length bit strings. The number of n length bit strings which have consecutive zeros. Okay. Now you can notice very easily that what is the possibility? What is the possibility? See, if the last bit is 1, okay, either the last bit is 1 or the last bit is 0. Okay, so this is the point. Either the last bit is 1, you can notice. If the last bit is 1 or the last bit is 0. If the last bit is 1, then what we want? This last bit is already 1. But what we want? We want consecutive zeros. Okay. So if this last bit is 1, then what we can do? We can find what is Tn minus 1. Here we must have consecutive zeros. If the last bit is 1, then definitely here we must have consecutive zeros. Yes or no? Okay. So this part must have consecutive zeros. Okay. So I can say that Tn is equal to, if the last bit is 1, then what I can find? I can find Tn minus 1. Means I can find number of n minus 1 length bit strings which have consecutive zeros. This part must have consecutive zeros. Okay. Now, okay. So this is over. So if the last bit is 1, then I can calculate Tn minus 1. Now what happens when last bit is 0? Okay. So this is done. In this case, I can count Tn minus 1. But in this case, if the last bit is 0, now, if the last bit is 0, then we have to be careful. Because maybe if the last bit is 0, then maybe this bit is 0 or maybe this bit is 1. So when the last bit is 0, we have to be careful. Okay. So if this is 0, then maybe the second last bit, maybe this is 0 or maybe this is 1. Now you can notice very important point. If these two are already 0, then we found it. What we wanted? We wanted consecutive zeros. We got it. We got consecutive zeros. So we found it. Okay. So it does not matter what is here. it does not matter what is here, yes or no? It does not matter what we have here, okay, because we already got consecutive zeros and this is what we wanted. So it does not matter what we have here, we will count it, okay. So whatever I have here, so all the n minus 2, this is n minus 2 length, okay, total n length I have, but the last two are 0 0. So this every string that I have here basically, okay, so every n minus 2 length bit string I will count. So how many n minus 2 length bit strings I have? Okay, so 2 power n minus 2. These many n minus 2 length bit strings I have. Okay, so all these I will count because I wanted consecutive 0. This is what I got. So it does not matter what is here, I will count it. Okay, so these 2 power n minus 2, this I will count. Now you can notice, if this is the case, now you can notice I must get consecutive 0 here. Yes or no? I must get in this part I must get consecutive zeros because I want consecutive zeros. So in this part I must definitely get consecutive zeros. So in this n minus 2 length, I must get consecutive zeros. So this is your Tn minus 2. So now you can write it. I can say Tn is equal to Tn minus 1 plus Tn minus 2 plus 2 power n minus 2. So that is your Tn minus 1 plus Tn minus 2 plus 2 power n minus 2. Okay, so this is the recurrence relation. This is the recurrence relation that we got it. Okay, so this is a very simple question. Let me summarize this. What we want n length bit strings. They should have n length bit strings. We want the number of n length bit strings. How many n length bit strings have consecutive zeros? We want consecutive zeros. Now you can notice, if the last bit is 1, then definitely I must get consecutive zeros here in this part. Okay, in this part, in these n minus 1 bits, I must get consecutive zeros. So I can write it Tn minus 1. Okay, plus if this bit is 0, okay, either this last bit is 0, either this last bit is 1 or this last bit is 0. If the last bit is 0, now I have to be careful, because if the second last bit is 0, this is what I wanted. I wanted consecutive zeros. This is what I got. So what I can say anything can happen here. Anything can happen here. I will count it because what I wanted, I have got it. So I will count everything that happens here. So 2 power n minus 2. Because this is the number of bit strings of length n minus 2. Whatever happens here, every bit string of length n minus 2 is allowed here. Because I wanted 0 0, I got it. But if this is the scenario, if the last bit is 0 but the second last bit is 1, in this case I should definitely get consecutive zeros in this part. Okay, in this part I should definitely get consecutive zeros. So I can say Tn minus 2. So this is the recurrence relation. Okay, so finally this is our recurrence relation, and initial conditions we have already seen. So finally Tn minus 1 plus Tn minus 2 plus 2 power n minus 2. This is the recurrence relation, and initial conditions we already have. T1 is 0 and T2 is 1. Now you can very easily find T3. T3 means number of 3 length bit strings which contain consecutive zeros. Now you can very easily calculate T3. Okay, so that is what T3 is Tn minus 1, means T3 is T2 plus T1 plus 2 power n minus 2, 2 power 3 minus 2. So that will be 1 plus 2, that will be 3. So 3 length bit strings which contain 0 0, which contain consecutive zeros. How many we have? 3. You can notice only 3 we have. This, okay, this or this. So only 3 strings of length 3. Only 3 strings of length 3 we have which contain a pair of consecutive zeros. Okay. So this is a simple question and we have done it. Okay, and you can check out the playlist. Okay, a lot of questions I am taking on writing recurrence relation. So for many of the counting problems, all these problems I am taking from the standard books. Okay, so we are writing the recurrence relation for many of the counting problems. If you understood this problem, then very good. If you did not understand, then you can watch the complete playlist. Okay, I am taking a lot of examples and all these concepts will be clear. Okay, thank you.